Hello once again, our most valued student. My name is Confident and welcome to our continuation of algebraic expressions. We've been doing quite a number of lessons, and in this chapter or in this video we are now focusing on factorization. So this is where we are in our grade 9 term 2 work, if ever you guys are following what the curriculum is focusing on, unless if your school is focusing on something different. But more importantly, it doesn't matter at what stage you're watching this video. This is for you who is preparing for your June or November exams. Those two exams are very important. You don't have to take them for granted. Look at this. It says factorization. It's a very important concept, and we are looking at the introduction. So I want you to have your calculator handy. There is my calculator, but I'm not going to focus on this one because it's limited. I have one in hand so that you can see how easier you can get started with factorization. So let's quickly jump into the lesson. It says factorize the following. And what is factorization? Let's start with the first one. It says we need to factorize 3x plus 6. Alright, so I'm just gonna take it like you haven't factorized. Of course I know you have done it at school, but I just want to lay a foundation here. 3x plus 6 now equal to, by factorization we are saying what is it that is common. Alright, what is common? So now look at this. If I say 3x plus 6, this is equal to 3x. So that's where I want you to take a calculator, and then you're going to express 6 in a different way. So what you do, you say 6 equal to, alright, so if you say 6 equal to, now my calculator doesn't have it, then you say shift. There is a button somewhere here on this part, I think just somewhere here there is a button. It says FACT. This one is an error, but if you press that you will see something different. It will give you what? If you say 6 equal to shift FACT, so 6 equal to shift FACT, you see that you got what? 2 times 3. Mine gave me that, but don't forget, don't say 6 equal to then you press that. No, you must say 6 equal to shift and then you press that. You see, then it will give you 2 times 3, so it's plus 2 times 3. You see, then already is showing you. I'm going to now look at 3 is there, 3 is there. You see, then it means 3 is common. And when 3 is common, now what is going to remain inside? Look what is happening. You are taking out 3 there, you see that is remaining, and you are taking out 3 there, you see that is remaining. So just repeat again. Whenever you are taking out the 3, it means that will be gone and that will be gone. Where is it? It's represented by that 3 outside. So you are having x plus 2. That's what it means. Alright, so what is the answer there? Is 3, and then it's x plus 2. So guys, you're factorized. 3 was common. How did you find that 3 was common? We used, of course, our calculator to get that. Alright, so far so good. Let's continue with the next one. What about 2 plus 12? I mean 2a plus 12. I'm going to use the same concept here for 2a plus 12. So let's do that. It's 2a plus 12. So what you do, you continue. 2 is already simplified. You can try it with the calculator. You say 2 equal to shift 2 plus, but do 12. Say 12 equal to, like I told you with the calculator, you take a calculator and then you say 12 equal to, then you say shift, you press that button, it will give you what? So shift that, it gives me 2 squared times 3 on my calculator here in hand is 2 squared times 3. Now I want you to pay attention now. Equal to, which is equal to, now something is interesting here. If you look at what is repeating, remember factorization is about what is common. So you can see that I've got 2 and I've got 2, but what is the power here? It's power 1. What's the other power there? It's power 2. Now you only, for you to find the factor, you look at the smallest power. That is the highest common factor, is the smallest power. So I'm going to take now 2 to the power of 1, which is simple as 2. Now when I'm taking it out, now what do I have? Remember I told you it's as good as you are scratching it out, so you're left with a. But here there were two of them. If I can erase here, it's more like we are saying there is 2 times 2 times 3. That is your 2 squared times 3. You remember, 2 squared means there are two of them. So when I scratch out this and I scratch out one of them, you see that I'm left with 2 times 3. You can see I'm trying to do this as slowly as I can so that you can see where everything comes from. All right, so now when I'm going to be doing now the normal factorization without doing that, you take out the 2 here. You are saying what is going to remain? It's a plus, now one of them is out, so there is one that is remaining. It's 2 times 3. Seeing that, which is equal to 2a plus what? A plus 6. 2 times 3 is 6. You have to take it back to that. All right, making sense? Let's continue. 8a minus 16. Same thing here. You can have 8a minus 16. I just want to make it as simple as is. I know you guys can simply say that 8 is common and then you get your answer. Like here, you say 8 is common, 8 will go, and then 8 into 16 is what? Is 2. So you'll simply have a minus 2. But what if I focus on the same method that I showed you? So you say 8 equal to shift, like take a calculator, and then what you do with the calculator, you say 8 equal to shift, and then you say 16 equal to, like 8 equal to shift, you press that, and then you do the same thing, 16 equal to shift, you press that, and tell me what you're getting. So for 8 equal to shift that, it's giving me 2 to the power of 3a minus 16 equal to shift that, it's giving me minus 2 to the power of 4. All right, I choose to do it this version. Now, what did I say? Always focus on the smallest power. Which one is the smallest power? 3. And then you take that out, which is 2 to the power of 3, because it was 2 to the power of 3 and 2 to the power of 4. So you take the smallest power. As you can see, 2 is the one that is appearing both. Now that one is gone. See, the 2 to the power of 3 is the one that is now represented. So that's why I can scratch it out. It's represented by that. You see, so what I'm gonna have, a is remaining here, minus, but I took out 3 of them and there were 4 here, so it's more like 4 minus 3, which is 1. You see that? So there is 2 to the power of 1. So the answer simple is 2 to the power of 3. It's 2 times 2 times 2. You can use a calculator then. It's 8a minus 2. As simple as is, I know, but going forward you will see the value of what I'm showing you. Now let's do next. 3x squared plus 6x. We want to factorize that. 3x squared plus 6x. Now remember, we did something on 3 and 6. We said it was 3x squared, so it's 3, that was 3x plus 6. Now it's 3x squared plus 6x is same as 2 times 3x. Remember from the previous shift, 6 equal to shift that. Now which is equal to, nothing has changed on 3 and 2. You can see 3 and 3, you take out the number first. Now on the x, which one is the smaller power? There it is, x to the power of 1. If you don't see any power, it means it's power of 1. This is 2, it's bigger, but 1, so we're going to take x outside. Right, so the 3 is represented by that 3. Now it's x squared, so if I've already got 1, so I subtract 1 there, it will remain with x. You see that? So what I have here, it will be only x remaining there, and then plus. Now remember, already I've taken up that 3, 2 is remaining on the other one, so it's 2. And when also x is also represented out, so it's just 2 there. You see that? So x plus 2. Why? Because there is 3x represented there, so you see the 2 is coming out. So that is how you factorize that. I hope it's still making sense. Next one, mn squared minus m squared n. Be careful about that one. It says mn squared minus m squared n. Let me just verify that. mn squared minus m squared n. Now this one also not difficult, but you need to be careful there. You look at the powers. What is the power of m? It's 1 n squared. Remember, the square belong to n. Now it's m squared, then n has a power of 1. Be careful of that. Now always choose the smallest powers. Look for m. M has 1 and n has 1, so which means the smaller power there is m n, which is 1 1. If you don't put any power, it means it's 1. Now when you take out m there, you see m1 is taken out, is represented here, and then n1, so you subtract 1 there. You see that you're left with n. So that's what you must be doing in your mind. You don't have to be writing this. So m is gone, but you have got n there because it was squared in here. And then minus m squared, you subtract 1 also because there is the other one. So what do you have? You have m, but n is gone. See that? So that is it. You have got m n minus m. That's it. Remember, when you open up this bracket, if you multiply this times this and this times this, you must get back to the original. For example, mn times n, it's m, there are 2 of the n, it's n squared, minus mn times m, it's m, there are 2 now, n. You see, taking us back there. Alright, then next one here, where are we? We're here, 2y squared minus 2y. This is the foundation, guys. This is the foundation. It's 2y squared minus 2y. Am I right? Yes. Now again, don't let it confuse you, don't let it be hard. Look at it simpler. 2 is already common here, but now y squared y, what's the power there? It's 1. Take out the smaller power, power 1, then 2 is already out. Now y1 is out, then there are 2 there, only 1 y will remain. Minus, look, there is 2y, there is 2y. Don't say nothing is remaining. Have a placeholder 1 represent that. So here when you cancel out, there is a 1 that will represent. You know why? Because if you say there is nothing, you are left, you're just going to say 2y, and then you're going to say y, and then you close. But if I say expand this, it will be 2y squared. Now where are you going to get the 2y? But look, 1 being the placeholder there, if I say let's expand this, you're going to multiply this times this, you see, and that times that, which is 2y times y, it's y squared. 2y times 1 is minus 2y. Where is it? There it is. Are you seeing what I'm trying to drive at here? I hope it's making sense. I hope it's making sense. Next one, 27. Let's look at this one here. I've got 27 m5 minus 18 m to the power of 3. All right, not a problem. What do? Do the same thing. 27 shift equal to, so you take a calculator just to remind you again. What you do, you say 27 equal to shift, you press that button. Let me use my calculator here. 27 equal to shift that, it gives me 3 cubed. Right, it's 3 to the power of 3 m to the power of 5 minus, I do the same with 18, equal to shift fact, which is 2 times 3 squared m to the power of 3. All right, don't have to stress yourself, just look at the numbers first. Which number is common? Is 2 common? No, 3 is common. Why? Because it's appearing here. There is a 3, there is a 3. Now since 3 is common, which one is the smaller power? There it is, 3 squared. That's what you're going to take out. So what you have on the 3, you're going to have 3 squared. Okay, and then look at the m again. M is common there, m is common, but the smaller power is what? m3. See that? M to the power of 3, not m3, so it's m to the power of 3 bracket. Now what are you doing actually? When you're taking it out, you are saying already 2 of the 3 is out, but here I've got 3. What is remaining? That's why you say minus 1 to say what is remaining. 3 minus 2, only 3 will remain to the power of 1. And then m to the power of 3, there are 5 here. What will remain? Only 2 will remain. Are you seeing that? And then minus, there is a 2, it will remain. 3 2 and 3 2, nothing will remain. m3 and m3, nothing will remain. It's more like you're saying times 1 times 1. Still fine to do that. But if you're multiplying times 1 times 1, nothing changes. You can still do that here. To represent this 2, you say times 1. m3, you say times 1. Are you seeing what I'm doing? Then that, but it doesn't change anything there. Then it's important to say what is 3 squared. 3 times 3. Please, it's not 6. It's not 6. I know you're saying 3 times 2. I say 3 squared. It's 3 times 3. It's 9 m3 and then 3m squared minus 2 times 1 times 1 times 2. There it is. And then you're good to go. Alright. So I hope this makes sense to you. Can we work this one here? Yes, let's work this one here. You have got 18 m to the power of 6. Okay, it's a bit too bright, but let's do it here. I feel like it's better down here. Let's just do it here. I'm just gonna clear some space here. Okay, let's just do it here. I think there is enough space for us to do it here. Look at this. It says we have got 18 prefer this one 8 m6. Okay, interesting. n4, all right, plus 12 x4 y 7. I think there was an error there on this, but it's fine. Let's do it. I don't think it wanted to say m and x. It wanted to maintain. Okay, let me just change it for the sake of this. Where there is x, I'm gonna maintain m. Let's say it was m4 and then n what? n7. Let's do this. Are you with me? Just to maintain it like that so that it makes sense. I think that's what the whole thing was. Now, what is 18? Calculator. 18 equal to shift fact. 18 is 2 times 3 squared, and then it's m6 and 4 plus what is 12? 12 equal to shift fact. It's 2 squared times 3 m4 and 7. All right, see, this is the foundation of factorization. Okay, look at this. Start with the numbers. I've got 2, what's the power? It's 1. I've got 2, what's the power? Is 2. Which one is the smaller power? Is that one, 2 to the power of 1. So we take it out. Very important, pay attention now. We take out 2, but I see that 3 is also common, you see, which is very important. Now I look at 3, what's the power? Here power is 2, here power is 1. So which one is the one I'm going to take? Smaller power is that one, 3 to the power of 1. Are you with me? So I'm going to say 2 times 3. See now how important it is. You can put the ones if you want, and then after that look at the letters m and m. Which one are you going to take? Power 4, of course. It's smaller power. I just want to maintain my marker. And then what about n? 4 and 7, it's n to the power of 4. Now on the first one, 2 is out, you see, but 3 is 2 and 1. I took out 3 there, one of them, so only 1 will remain. m4 and 6, 2 will remain. n4 and 4, it cancels. You see, this cancels, but here it will be minus 2 there. Are you able to follow up now? I think you're following up, right? Now plus again 2 squared, it's 2 with only 1 will remain, and then 3 will go because it was 3 and 3. Look at the m4 also gone. What about n? n4 and 7, it's n to the power of 7 minus 4 is n to the power of 3. That's it. Then you multiply 2 times 3, it's 6 m4 and 4. Then you've got 3m squared plus 2n3. Then that's it. You are done. as good as done. Good as done. Good as done. All right. Anything else? Yes, we still have the last one. I like the last one because it is kind of a little bit more. I think it's how many times? 3 times there. Let's look into it together there. What do I have? I have got 9x to the power of 3 y to the power of 7 plus 54 x to the power of 4 y to the power of 8 minus 63 x to the power of 5 y to the power of 9 z to the power of 2. Interesting. What do you think? Also, nothing looks, it's just addition of extra stuff, but please don't confuse yourself. Check a calculator. Style 9 equal to shift fact. 9 is commonly 3 squared, you remember that, x cubed y7. So the only thing you need to convert is this. We say as multiples, the product of their prime numbers. That shift fact, we are converting them as the product of their prime numbers. So what is 54? 54 equal to shift fact. It's 2 times 3 to the power of 3. All right. x4 to the power of 4, y to the power of 8 minus, what about 63? 63 equal to shift fact is equal to 3 squared, all right, times 7, x to the power of 5, y to the power of 9, z squared. Okay, equal to, just look at what is repeating. I've got 3, 2, no, I've got 3, 7, no, I've got 3. I focus on the smallest power. 3 squared, 3, 3, no, I need the smaller power, which is 3 squared. You see that? So 3 is common, so it's what? It's 3 squared I'm looking at. That's the smaller power. Is there anything? No. Focus on the letters. X is there, x is there, x is there. What's the smaller power? 3, 4, 5 is 3. So I take x cubed. Do the same thing with y. y7, y8, y9. Okay. I've got what? y7. Z is only appearing once. That's it. 3 squared, 3 squared, x cubed, x cubed. So all these are represented on here. So what is left? y7 is also represented here. So what will represent that? It means I must come here and put a 1. Are you with me? That's what it means. Put a 1 so that when you multiply, it will represent that. And then plus, don't say nothing. Put a 1 as a placeholder there. 2 is not there, but 3 squared and 3 cubed is times 3. You see, I'm going to cancel the 2 here. Actually, it's 3 minus 2, which is 3 to the power of 1. 3 to the power of 1 is same as what? Is same as 3 here. Then y7, y8, what is remaining is only y to the power of 1. Because there is 7, 8 minus 7 is 1. Minus 3 squared, that goes, but 7 remains. See that? So it's 7, x3, x5, how many are remaining? 5 minus 3, it's 2. And then y7, y9, y7 minus 9, 2, and z squared. That's it. That was the answer. Then you can simplify to say 3 squared, it's 9, x cubed, y7, 1 plus 3 times 2, it's 6y, minus 7x squared, y squared, z squared. Then you're good to go. You have done what is called factorization. No matter how complicated it look like, you just have to follow the first rule we did, the first one, this one. That's where everything started. So guys, we're done on this lesson. Join me in the next lesson. What's happening in the next lesson? Look at this. We are now factorizing involving brackets. Very important one, as well as the changing of a sign here. So I just want you to join me, as well as guess what? Factorization by grouping is also coming soon. Don't forget. Not only that, factorization as a difference of two squares. Very important. Alright, so what am I saying? Subscribe, guys. If you're not subscribed, you're missing out. Subscribe. YouTube is going to notify you every time I put a new video. And these videos, sometimes they are split. As you can see, find that because of time, I have to separate these videos. I can't teach everything at once, so that you don't stay hours and hours. So you get this concept. Now you watch the next video for the next concept, watch the video for the next concept, and so on. So guys, you've come to the end of our lesson. Share the channel, comment. What are your comments? Talk to me. I need to know there's someone who's watching this, and I need to hear your thoughts. We have come to the end of our lesson. Thank you.